I'm Mazhar. I'm a software practice lead with Confluent, and today's talk is going to be about how to save your jobs. Okay, maybe it's not about how to save your jobs, but in a way it is. A lot of us are engineers, data streaming engineer, data engineer, software engineer, we're engineers and we like to be proud of the products that we build. We like our products to work. We like our products to sort of provide a good UX to people. So we really want that artisanal effect when we build things. So there are two pillars to doing that, right? Assuming you know what you're doing and you're building stuff that people want. Nobody runs your stuff, that's a whole different problem. But the first pillar is testing. Right? And again, this is not a talk about testing. It's about why we are going to talk about the things we're going to talk about. So when we're doing testing, lots of different types of testing. I know you all do testing. Software is complex. Distributed software, streaming software, is even more complex. So the onus on testing becomes much, much larger when you're working in a streaming application. So that's the first one, and that's where our talk's going to be. Of course, testing, pretty much doing anything doesn't matter if you can't see the results. Shoot, I still haven't figured out how the clicker works. Okay. And of course, the second pillar is monitoring, right? You have to know what it's doing. So as a good engineer, you build your product, you test it until, it never fails no matter what you do. But you have to have monitoring because it will fail. Through no fault of your own, it will fail. And so you need to have enough information to make a good deduction on why it failed, and then quickly fix it, and so on and so forth. So these are the twin pillars of designing good, robust systems. And what I want to talk about today is that testing part, and specifically having good test data to test your streaming application with. I was going to get back to the title of the talk eventually. So we're going to talk about, just a sample streaming application. What is the sorts of things that are different in streaming applications compared to normal applications like Microsoft Word or a browser? A browser is kind of distributed. Okay, fine. Okay, and then we're going to have this big question, right? Sure, the perfect test data is production data. Let me grab a bunch of that and run it through my system. System is tested, we're good to go. Maybe not. We'll talk about why not. Right? And then we'll end up with looking at a bunch of different products, a bunch of different applications, and then maybe, since I am a software practice lead, I will talk about the practice of software as well throughout. Okay, so we have a streaming application. This can be any streaming system. I'm using Kafka. There's producers, there's consumers. That's what we start off with. We build our application. We want things to work. Then, and then maybe it's not so simple, right? You have real life business requirements and you're like, oh, okay, you know what? I need a sink or a source of some sort. Let me use Kafka-Connect and let's hook things up. Let's get more data flowing into our system. And okay, fair, we're getting better. And lastly, you have to transform your system. So you've got data coming in, you need to aggregate it, you need to do something else with it, you need to join it to data, look up data from somewhere else. So now you've got a more realistic example of what a streaming application is. And that's what we're going to use as far as running our streaming test data. Okay. So you're in your development environment, you've got this application up and running, you maybe use the Kafka CLI to submit some test messages, maybe those messages are in a file and you're just streaming the contents of that file, one record at a time. And okay, I've written some stuff, and okay, some of those messages are critical because you or the person writing the application knows the most about their application, so you definitely need a few records or messages that are relevant to your specific application. But you're not the first person to reach there, right? There's people out there who built streaming applications and they've written lots and lots of test generators to help you do your test. So this talk is about convincing you to try all of them, figure out which ones you like better. When I say like, it's not a personality thing, it's a this does what I want it to do thing. And then hopefully I've reduced some of the work that you guys have to put together for your next data streaming application. Okay, so when we moved to data streaming, the first thing that we talk about is performance, right? The whole reason we moved to data streaming was because we wanted more fresh data and more live data. So the first thing we always want to test for is performance. Fair enough, latency, throughput, messages per second, that sort of thing. So we need something that will just let us kick the tires. We need something that'll just bang, can I stuff 5,000 messages per second through this thing? Right? If it can't, maybe it's not fulfilling your business requirements. You need to redesign, re-architect, figure out how to scale this thing. So that's the very first thing. The next one is functionality. Obviously, it should do what it does, but now you need to send it something more than 5,000 messages per second. You need to send it 5,000 specific messages that exercise the functionality that you've written. And lastly, you do need to put some testing in so you get erroneous data, right? Does your code degrade gracefully? I love that term, degrade gracefully. Usually there's nothing graceful about failures, everybody's screaming, your customers are calling your CEO, but you should know how your system will perform in the event that it gets data that it did not expect. Right? So degrade gracefully. Okay. What did I do? Right. So given all these different criteria, let's go back to the first question, right? This is the big question that I want answered. If you take nothing else away from this presentation, what I'd like to take away is why not production data? Before I go into the next slide and talk about why not production data, how many people use copies of their production data to test their streaming application in dev? All right, so we've got 3, 4 brave volunteers. We're still friends, it's okay. And yes, there are legitimate reasons to do that. But let me talk through some of the reasons. Sometimes, this talk is targeted, sometimes people assume that they can get to production data and they'll eventually get to it and they'll run it through their dev environment, but there's many reasons why that doesn't happen. First and foremost, PII, privacy, right? We've got so many different legal frameworks that talk about how you cannot identify someone, financial records, medical records, almost anything. Right? And if you've ever worked in a very large data environment, you know how hard it is to take somebody's name out of your 5 petabyte data set, right? You can search it maybe, but delete it. So it's tough. And people are always scared of giving you access to production data because even though you can say, look, field A, field B, field C, it's not PII, it's possible some weird combination of B and C with some public data is PII. And you're still legally responsible. So your legal teams will push back every time you say, hey, I want copies of my production data in my dev environment. Why? Because your dev environment is less secure. You're allowed to do whatever you want. You can become root on it, right? You become admin, you mess around, do whatever you like. It might leak out. So number 1, privacy concerns. Number 2, production data, your snippet of production data may not have the edge cases that you care about, like the ones that will break your system or explode your local state storage. So how do you know, how can you test those things if your 1 month of production data never had that particular situation occur, but the very next month it does when you deploy your system, and now you're in trouble. So it's not comprehensive enough. This one, if you work for a large company, you're very, very familiar with this, right? Security. Your security people will not let you cross the streams and say, hey, I want to connect from dev to prod and pull in prod data to test my system, right? They don't let you go across firewalls. You start asking for holes in the firewalls, everything's a mess. So it is usually very hard to get access to the production system directly. You end up having to take snapshots in prod, save it somewhere, get somebody to sign off on it, move it somewhere. It's exciting. And lastly, your streaming system might not be the 5,000 messages per second every single second for the whole year. It's, a message a minute. So you don't accumulate enough production data that's relevant for your test cases. Right? So those are my 4 main reasons for why when you're building an application, you shouldn't really expect to have access to production data to make it test. I was just sitting in a talk with Simon Aubrey, and he was giving his years of experience with Kafka, and he was saying, something about some of these rules don't apply if you're a very small company or a very large company, right? In both cases, kind of everybody who needs to know everything is right there. So, and we can talk about that in the Q&A afterwards if that doesn't make sense and I'm just rambling. Okay, so if we're not allowed to use production data, and I'm sitting here telling you don't write your own Java, Python, Go application that will generate your synthetic test data, what are your choices? Well, there are plenty of synthetic data generators out there. And again, just going through the three main characteristics that we talked about, performance testing, latency testing, functionality testing, and erroneous or abnormal data testing. So let's take a look at some of these tools and see which ones can do what for us. And I'm going to go in terms of complexity. So if the simpler one solves your problem, use that. And if not, you'll have a good reason why you need to invest time and energy into actually putting together something slightly more complex. Okay, so you put together your system, you kick the tires. I want to test my throughput. Right? That's what I do for the very first time, whether I'm working in Docker, whether I'm working against the cloud. I put together a Kafka application and I say, hey, can it even do what I'm wanting it to do? And so for that, it's free. You've got a built-in Kafka producer test client with every Kafka API, with the Kafka SDK, or download, I don't know what they call it anymore. And it's got a lot of good parameters. You can tell it how fast, you can tell it how many bytes per second, you can tell it how big the messages should be. So you can really test out the pipe pretty well. And it kind of sends something like that. So the last time I told it to dump out a message, that's what it looks like. So it's just a bunch of bytes, and it sends them. So you are getting, essentially, can I get n bytes per second through my system? Which bytes you don't get to know. Is your compression algorithm good for the kind of data that you're working on? Is it good or bad? You can't tell from this data because the producer test client generates random bytes. So that's your first solution. You're like, wait, we came here to listen to that? No, there's a bit more. So the next one is, let's say you're a little bit more complicated, right? You're not simply like log shipping, right? A very common, the first application of Kafka is you got 15,000 machines or containers or VMs, and all of them have processes running. You want to take their logs, ship them into some sort of warehouse, Splunk or something, and index it, and then query it. So you don't really care. You don't care about the format. You don't care about the internals. You just want to send it. But let's move on from that to something a little bit more complex. You want to transform it. You need to know what's inside it. So for example, here's a message. It's got some sort of epoch, I never get it right, user ID, region ID, and gender. And what you want to do is transform that into maybe a regular timestamp, maybe something that's ISO 8601 compliant. So you need your synthetic data generator to generate that particular field with that kind of number. And maybe you need to be able to tell it what the range of that number should be. You don't want to be working on BC type dates. Okay. How are we on time? So for that, we've got a nice little tool, Kafka-Connect based, a datagen connector. Okay, I'm going to say it. The downside is it's part of Confluent platform and Confluent Cloud. So open source Apache Kafka, some of the other platforms, maybe you can't use this, but it's really clean and it's my first go-to thing when I want to put together some mock data for an application. It's based on Avro. So if you look on the left, we've got the Avro schema, and the Avro schema tells you, okay, I have field A, field B, field C. I can't even read my slides, but essentially if you look at the top, it says, hey, here's a regex that says that this field should be generated as region, and then randomly pick 1 through 9. And the Avro generator, whose author might be in the audience, is what runs underneath the covers to actually be able to pick up and run, generate all that data for you. So 2 different fields, pick from a list, match that regex, and it starts generating these for you, and they keep changing for you. So it's somebody's thought through a lot of the problems that we have when we generate our own test data, and they've given you lots and lots of different options. They have, a lot of these tools have user contributed or built-in templates and libraries. So, there's tools that you can say, hey, choose from a list of Greek philosophers, and you don't actually have to put that together. Somebody made a list and put it somewhere that you can use. So first thing you've got to do is make sure that the simpler tools are matching. And there's a lot of different users. I think for the Datagen connector, you've got things like users, products, and things like that. So business type stuff. So the next one And this one is the one that gives you like a lot of freedom because it's in code, right? So almost every programming language has a faker library or some variant of a faker library. We have Python fakers, Java, Data Faker, and Flink Faker. I'm sure there's others that I'm unaware of, but these are things in programming languages that come with a lot of libraries and support for you to generate things. Let's take a look at a few examples. Are these readable? I don't know. Anyway, so on this side, we've got Python, and I'm just saying, pick in the Faker library. I'm going to localize it to 3 different languages, and then I'm just going to say print name or print address, right? Really simple stuff. I'm not here to tell you about APIs and how to see what they can or can't do. I'm just giving you examples of what other people have already done so you can steal it. Or, yeah, you know what I mean. So as you can see, it actually does obey localization as well, so you can check if your application works well with those sort of things. Because now we're looking at the case where we care about the contents of our message. The downside with the Python Faker, it's a Python Faker library. It generates this data. It's up to you to wrap it together into a testing framework, into a harness, and feed it into Kafka, right? So you get this maximum flexibility because now you're programming in any of the languages. I'm not preferring Python Faker to any of the others, but you still have to put it together into a system that can feed your data streaming application. So I put this in for Flink Faker because this is different. This is the one that's different, right? So how many people here are slightly familiar with Flink? Okay, so a few. So Flink is a stream processing engine. Thank you. So a few people. It's a stream processing engine, and it has the ability to make stream processing look like SQL. So you can pretend that a stream of data coming from Kafka is actually a table. And you can select from that table, you can do where clauses, you can do aggregations. So here, we're making a fake table. It's a source, and it says, hey, here's these strings, and the with part is what tells you use the faker, which is built into Flink. And now you can provide parameters like number of rows per second, number of things, and off you go. So super fast to test your application. Okay, so we've talked about the case where we didn't care about the contents of our messages. We've talked about the case where we cared about specific contents because that would exercise our functionality. The third piece, which is the most normal one, is when you've got stateful aggregations or stateful processing, where somebody has to remember something in order to process the next message. This could be something, well, stateful, like joins, right? You've got 2 data streams coming in, and they'd like to join on a particular field. So those fields should have values in common. Everything we've seen so far doesn't do that. It generates fields, and you're going to be in trouble because joins will rarely work or work really badly. So the 2 tools I'd like to talk about for this particular case, and these are the most complex tools I've got for today, are JR and shadow traffic. So to give you an example of how JR does joins is the top is one data stream definition, and the bottom is another. And in the top, it says, add a value to a list for a particular shoe ID. So it generates a random shoe ID based on some specification that you've got. And then it says, add it to the shoe ID list. And then in the order, it says, go look it up from that same list. So it creates an in-memory list. So every time it creates a random value for that particular field, it puts it in memory, and then the other stream can pick it up or look it up. And now you've got something that can still do a join as you go forward. These tools have a lot of other features as well. I'm just kind of giving you a flavor. A similar example, but using shadow traffic. So shadow traffic is the most complex one I'm going to mention today. And what this does is that, well, shadow traffic uses functions to generate values. And there's lots and lots of functions and different things you can do. But just to give you an example, you've got customers and it's got a name, and then orders needs a customer ID. So it can actually go look up the customer record that it had generated for customers and pick out the name, based on the name, pick out the customer ID. So kind of SQL-ish, but still, it's the configuration in shadow traffic is all JSON. I'm giving you a feel of how to use it. And a special treat, this current, is that you can talk to the person who created it and I think they're giving a talk tomorrow or later today. I know it's after me. So yeah, so that's the most complex one. You can do this. There's tons of functions that these tools have, both JR and shadow traffic. And like I said, my policy is pick the simplest tool that fulfills all of your requirements. Okay, so last piece that I want to talk about is abnormal situations. We figured out how to generate data for all good days, but what about the bad, erroneous conditions? For really critical bad conditions, you want to go back to programming, generate your data, get your timestamp offset. I'm pretty sure some of the other tools have the ability to give you those sort of, oh, this packet is more than 5 seconds late, and I had a window of 5 seconds for my aggregation, so this one shouldn't be in it, or whatever. So you can do it in your code, or if the tool supports it, do it in the tool. It's always better not to write code. The last piece of error checking, right? What happens if your network fails? What happens if the machine dies? Right? All those different system level errors. There's a whole field of chaos engineering. I'm just going to give you the word. Go Google it, ChatGPT it, obviously, if you haven't played with it. But every good company with a large data center does this, right? They figure out how to crash things. Also, if you're going to look at network issues, you can wrap some of the tools that we've talked about inside some of the load testing tools that already exist, right? JMeter, Gatling, all of these tools have pre-existed. They're mainly used for things like web traffic, but you can wrap them around your stuff. Most of them have a Kafka plugin, and you can use those as well, because these other tools, because they were designed for monitoring, they give you really good feedback. They give you monitoring without you having to build monitoring into your application for all of this extra testing. So don't be afraid to mix and match. One thing that I haven't put here that I just recalled, if you want a flaky network interface, right? If you want to test, well, how does my thing behave with a flaky network interface, Linux actually has a traffic control utility, TC. You can use that to say, hey, use a normal distribution, introduce a latency of between 100 and 150 milliseconds, and it will just do that at the network interface level. So no changing your code, no changing anything, turn it on, run your tests, turn it off. Almost anything else that tries to introduce these latencies is either built into the tool itself, so things like shadow traffic will let you tweak the pattern of the traffic being generated, or you have to use a proxy, right? You can't no longer write to the raw network interface. You have to talk to a proxy who will do all the delays and crashing for you, and then that will connect to your cluster or your application. So I found TC to be my go-to thing many a time. Okay. Wrapping up. No sigh of relief. Okay. Wrapping up. Yes, for the 4 people who said that they can do production data, you have valid reasons for doing production data. You know, there are tools now, and a lot of them are AI-based, that will take your entire petabyte data set and make sure that there's no PII in it. Or they'll take a few example messages and then auto-generate, 50,000 versions of it that are still compliant with what your original messages said they would be, right? So city names, things like that. It can expand, right? That's what, okay, I'm not going to insult anyone, but if I have 3 examples of something, AI is really good at generating a few more examples of it with slight differences. So that's all out there. There's lots of commercial products. I've got them in my references. The slides will be available to everyone. So they'll help you do that. Generative AI, absolutely. Who's that company? There's a company, synthesis.ai, that is basically generating data that people are training AIs on. Right? So if your streaming application is something with RAG or some other thing that you want to do that, here's something that will generate consistently some data for you to work with. All right, and these are just examples, so we're going to skip that. Here's my comparison separator to tell you, simplest to harder to implement. When I say harder to implement, I don't mean it's hard for you to understand. You're all engineers, you're all going to get it, that's easy. It's just that you as a firm will have to put some investment into saying, we need this, right? So once you have a good understanding of why you need it, it's much easier to say, the firm should invest in it, everybody in the team should learn it, and so on and so forth. It's not a single person thing. The first 1 or 2, and that's there. Like I said, the slides will be available, so feel free. Okay, because I'm in software practice, not that many people know what practice stands for. You have to do things right. When you're testing things, you have to follow all the other rules that you do for normal code, right? You need to do that for your test data, right? So DevOps, anytime you change your test generators, anytime you have like snippets of code that you want to send, snippets of messages that you want to resend, you've got to do standard GitOps, DevOps type of practices, right? It has to be something that you can recreate, you can regenerate as you go. The easier you make it, right? So you wrap all of this, whatever tooling you come up with, whatever tests you come up with, the more you wrap it into something nice and easy. People make a change, they run the test, it works. That's good. People will run things if you make it easy for them. A particular issue is schemas, right? People always say, oh, I updated my application, here's a new field in my schema, let's go ahead and run it now. Does it still work with the previous schema, right? With previous data? Right, so schema evolution, backwards, forwards, something you need to keep an eye out for this test data, not just your main application. Last piece, I keep saying last piece, monitoring, right? All of the streaming data, it's kind of hard to say, did my test pass or fail, right? If you said dump 5,000 messages per second and you're looking at a chart and saying, okay, sort of, you really want to have like a pass-fail thing, right? You want to have an integration test suite and say, bam, 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 here's my 20 tests, they all passed. So implementing monitoring in a way that you can check the results in an automated fashion, right? This might be, you might be pushing logs, metrics, traces out specifically so that your testing is easier, right? So don't forget, if you can't measure what it is that you did, and as good engineers, explore. There's lots of different tools out there. If you can't find anything useful, write one. If you're a good person, open source it. Hey, that works. If there's already something that's open sourced and it's not working for you, but it's only a small change, fix it, contribute it back. That's how we as engineers do good. Okay. I work for Confluent as a software practice lead. We have a site called Confluent Developer where we have a lot of free courses, things, useful stuff, even though I wrote some of it. And then we are done. Well, thank you all very much.